Hello ladies and gents, welcome to another repair video. Today we're going to be working on this PlayStation 4 which has been sent in. This is the 1200 series model and that's the one with the clicky button. And this particular console has a couple of things wrong with it. So first of all, it's got on the ticket no power. And then it's also got laser and loud fans. So I believe this probably has a disk drive issue and also the fact that it now has no power. But the interesting thing here is that it also says loud fans. Now, the problem with overheating on the PlayStation 4 is that the solder on the APU and South bridge is not so good. It's not so clever, and that was a fault of Sony's. But when the console continually gets hot and then cools down rapidly, it causes the solder balls to fracture. So what I think is happening here is it's possibly got an issue with the South bridge. And the South bridge controls all input and output devices along with some of the power rails. So basically it provides 3.3 volts for standby. I believe it's 3.3. It could be 5 volts, but I believe it's 3.3 volts for the standby. And it also provides power to things like the disk drive, the fan, the HDMI circuit and several other things. So when we have a fault with the South bridge, we typically either get a 6-second pulse in blue light of death or we get complete no power. So that's what I think is going on here. It could be that the disk drive wasn't reading because of the South bridge being on the way out and then suddenly it's just died, or it could mean that we've got to change the laser on the disk drive, but we're going to find out. I haven't turned this on yet, so we're going to see what's happening with it for the first time together. I'm going to remove that so I don't have to blur it out anymore. There we go. Okay, so let's try and turn it on. Okay, and no response from the buttons whatsoever. Alright. Well, the first thing I always do when we've got no power on the PlayStation 4 is to plug in a controller, just to see if we get any power to the front USBs. Sometimes the customer or the user has that turned off, the supply power to USB ports, basically when it's turned off. A lot of customers actually have it turned off and disabled, but it is what it is. We don't get any power to the fan, so the next thing I'm going to do is check and see, sorry, not to the fan, to the controller. And the next thing I'm going to do is check a disc and see if it'll turn on with the disc. Nope, so we've got complete no power. It is totally dead. Now the interesting thing is on the ticket it did say internal power supply replacement. That is just a thing that Console Repair London books all no power consoles in for, because that's all he can do in his workshop. He can't do the BGA replacements and things like that. So basically if it's not the power supply it gets sent to me, and here we are. So yeah, that's the situation. I don't need to test the power supply because that's been tested, or at least it's usually been tested. So let's just take it apart and we'll see if we can get it fixed. So we're going to get these screws out of here. It's a little bit stuck on there. It's a nice console, the white PS4. I've always liked that. Always liked the white PS4 1200 series, and yep, very, very dusty indeed. So probably going to need the South bridge replacing, to be honest. And that's generally the first port of call for a South bridge, for the no power issue on the PlayStation 4, is to check the South bridge. It could well just be the PWMIC, but that's very unlikely. Or not very unlikely, but it's a little bit more likely that it's a South bridge issue. So the first thing I'm going to do is reflow the South bridge, because that typically fixes a lot of power issues. And if it turns on, even briefly, even just for a second, if it turns on reflowing the South bridge, I will replace it. They are replaceable, contrary to popular belief. So basically just reflowing the South bridge would be a viable fix, but I'd prefer to replace it if it fixes the issue. Now, if it doesn't fix the issue and I can't see any other signs of anything, then I'm probably just going to replace it anyway, to be honest, because it could just be totally dead. But reflow is always my first option, just to see if it makes any difference. And yeah, this is very, very dirty, so this could actually have an APU issue. It very well could have an APU issue. That is a possibility, which would be rather annoying. I mean, fixable, but annoying. Typically, reflowing the APU fixes them. Could reboard it as well, but reflow is a lot easier and a lot quicker. It means I can get more done and charge less. And it's, to be honest, I don't really have that many PS4s come back when I do a reflow on the APU. So a lot of people will suggest that reflowing it isn't fixing it, but in this case with the PlayStation 4s, it is. If it was an Xbox One, I'd totally agree. But with the PlayStation 4, it's definitely a viable solution. Okay, and almost ready to get this out. I'll clean those thermal pads off later, should the need arise, if we actually get it working. Whoops, wrong screwdriver. Okay, so like I said, this is very, very dusty. Very dusty indeed. And unfortunately, there's no real way to test the safe bridge. So, literally, we just hit and hope, sort of thing. So the first thing I'd do is make sure 100% that the button isn't at fault. So obviously these ones have got a power button, not a power touch sensor. So the first thing I always do is just make sure that we've got continuity on the button when it's pressed, just to make sure that the button's not at fault. So if we pop one probe on ground, we've got the multimeter in continuity mode, and we pop one probe on the button and then press it. Yep, the button is working. Okay, so the button works absolutely fine. So basically the way the button works is to tell the console to turn on the voltage rail for the button. Like I said, I can't remember which one it is. It's either 3.3 or 5 volts, but the voltage rail for the power button is pulled down to ground when it's pressed. So it's basically the button just basically shorts out the voltage rail to ground temporarily, and that basically tells the console it's time to turn on. So we do have a RT5069 PWM-IC just here. It could well be that. Very well could be that. But it could also be the safe bridge. It could be a number of things. It could also be the APU, but I'm going to say the most likely scenarios here is going to be the safe bridge, or it's going to be the PWM-IC. I don't think it'd be the APU, just because that normally causes a blue light of death, not no power. So what I'm going to do first, the easiest thing to do, is to reflow the APU. Not the APU, sorry, the safe bridge. So I'm going to set my hot air to 460 degrees at 40% airflow. And I'm going to add some flux. I almost used thermal paste as flux then. Whoops. So I'm going to add some flux around the safe bridge here. This is the CXD90036G for the 1200 series safe bridge. And like I said, this controls all input and output devices along with power rails as well. So if this isn't here, the console isn't turning on. And if it's dead, then it sees it as not being here. So 460 degrees, 40% airflow, and all I'm going to do is just hold over the heat at a distance just until we get some temperature into the board, and then I'm going to move in closer and start to reflow the actual chip. You'll notice I've took the nozzle off my hot air gun. That's because it's a pretty big chip, and to be able to reflow this chip properly, we need a big nozzle. I could use the BGA workstation, but not a lot of people actually own one, so wherever possible I don't use it. I'm just coming in closer now, and I'm going to get ready with my tweezers and start moving air around a little bit. So every few seconds I'm just going to tap the chip and basically just check and see if the solder balls are melted. A very light tap will basically knock the chip slightly out of line but not off the pads, and then it should spring straight back, and that will tell me that all of the balls are melted underneath the chip itself. Okay. And that's reflowed. So let's give that a minute to cool down, but while we're waiting for it to cool down, I am going to clean it up using some isopropyl alcohol and a cotton swab. I've just spilt a little bit of isopropyl alcohol on the power supply. It won't hurt it though. So I'm just going to give this a little clean. Just get rid of the majority of the flux from around here, and then I'm going to use a toothbrush to give it a proper clean. So now that's cooled down a little bit, I'm just going to plug the power supply in. I'm not going to put it back together. I'm going to plug the power supply in, pop in the power lead, and there we go, that's turning on. But it now has a 2-second blue light of death. Oh, that's typical, so he's probably got a bad APU as well. Well, that sucks. That really does suck. Alright, well, I mean, I don't think it's going to be the power supply. Did I unplug that before trying to turn it on a second time? I don't know. If I didn't, then it's not the power supply. Could have just been overheating. I think it was just too hot. Okay, well, that is turning on with a reflow on the south bridge, so I'm going to get that south bridge replaced with a new one now. I mean, these particular chips cost around about £6 or £7 each, around about $10 US. So it's not really going to affect the price by replacing it rather than reflowing. And if I replace it, I know it's got a brand new one on. So I'm going to do the same again, but this time I'm going to remove the chip instead of just reflowing it. These tweezers are a little bit bent now. Okay. So there's the old chip removed. So now what we need to do is we need to clean up this area, clean up all these solder balls so as there's no solder on the pads, and then we can pop a new chip on. So I'm going to get this under the microscope so we can see what we're doing better. Right you are, so here we have the area where the south bridge usually resides. So what I'm going to do then is I'm going to get my soldering iron. I'm going to replace the solder that's on there at the minute, and I'm going to pop some fresh leaded solder on, and then I'm going to wick it away so as it's nice and clean. And the reason we do that is because this is lead-free solder that's on here at the minute, and basically by wicking away the lead-free solder we're going to do damage to the pads. So always replace the solder that's on there with some leaded solder just to lower the melting temperature and prevent it from damaging anything when we start wicking away at these pads. Remember, these are around 0.5 millimeters in size, and it's not hard to damage them. Let's just put it that way. It's not hard at all to damage the pads. And if we damage the pads, then we're in big trouble. So I'm going to add some more flux. You'll notice I didn't clean the old stuff away. It's kind of pointless. And I'm going to take some leaded solder and my soldering iron. I'm going to add a blob of solder to the iron, and then I'm just going to go around very lightly in a circular motion. Very little pressure on the south bridge itself, or rather on the pads themselves. For some reason my soldering iron's just gone to sleep. I left my micro pencil inside the holder and there's a sensor on it. So very lightly in a circular motion. And like I said, all this is doing is just replacing the solder that's on there to prevent us from damaging the pads on the motherboard. Okay, with that out of the way, I can start to wick away at the pads now that it's got some fresh leaded on there. So I'm going to use some 2.5mm wick, and this is just basically copper braid, but solder absolutely loves copper. And when mixed with a bit of flux and then the soldering iron applied onto it, we end up sucking all of the solder off the pads. Okay. So even though that seems clean, I'm going to give it one more pass. Remember, we want these pads as flat as possible. We don't want any solder left on them, if we can help it. And hopefully for the customer, we haven't got to replace the disk drive. Okay, so that should be good enough. So what I'm going to do then is just clean it up using some isopropyl alcohol, get rid of that burnt flux, and then it's ready for a new chip. VGA work is actually fairly simple when you think about it. Okay, so I'm just feeling around with my finger. That feels nice and flat all the way around. So let's just dry that off. Make sure we've got a nice clean surface to work with. The hot air will dry most of this isopropyl alcohol away, but I'll just get rid of some while I'm at it. There we go. And now we're ready for a new chip. The dogs have started barking at the perfect time, of course. So here I have some brand new CXD 90036G chips, which I bought from AliExpress. I'm going to take one out of the packet. And as you can see, the solder balls are pre-applied onto the chip. So let's get this in the right place. And there's a dot on the chip itself, and that lines up with the dot just here on the motherboard. So what we're going to do is we're going to get it roughly in the corners, and then I'm going to press down on the chip and just wiggle my finger around. Just make sure it doesn't move out of place, and that's going to tell me that it's in the correct location. And then because I've been pressing down on the chip with my finger's probably stuck to it. So I'm going to press down with the tweezers, lift my finger away, and as you can see there is a mark there where my finger is stuck to it. And then I can lift the tweezers away. Okay, so you'll notice I haven't added any flux yet, and that's because I don't want this chip to start floating around everywhere. So let's just apply some hot air. And once I've applied a little bit of hot air, I'm going to add some flux. Reflow. So I'm just literally holding the hot air dead straight. Can't keep my right hand still. Okay, and that appears to be installed now. So let's just take a look under the scope at what it looks like. And I might have messed that up. I think that went a bit wrong. Yeah, this probably isn't going to turn on. It might still be in the right place, but doubtful. So I might have to replace that again. Yeah, I've got to do it again. I knew it was. I don't know why I tried. Oh dear. Well, I'll probably skip through this bit. It must have come out of line. I could just try reflowing it, but I don't think it'll work. Alright, let's give that a whirl. Probably not going to work. Probably still going to replace it. Yeah, okay. Well, that kind of sucks. Okay. Alright, well, I probably used too much heat on it by the time it actually flowed into place properly. Right, you are. So let's get this cleaned up again. And I said BGA work was easy. And this time a little bit of conformal coating has come off some of the traces. I'm going to have to sort that out. Okay, so I'm going to clean this up. And that's nice and flat. Let's use the cheating option and just dry it off like this. Okay, so let's fix these pads, shall we? These are probably just ground, honestly, but I still need to sort them out. So I'm going to get some conformal coating or some PCB solder mask. I'm going to drop a bit just off to the side, so just up here, so as I can manage it better, because we really don't need a lot at all. And then I'm going to take a little bit on my tweezers, just a dab, and just paint these traces, just to prevent the solder balls from becoming misshaped when I resolder them on. So basically, by adding this conformal coating, it prevents the solder from moving and adhering to where the traces are exposed. A couple of little bits over here. And that should do it. That should be good. Alright, so the way I'm going to cure this, because at the minute it's just a liquid, but the way I'm going to cure this is using a UV pen. So, epilepsy warning, if you are epileptic, please look away now. So what I usually do is just turn the light off, and that way I can see the UV pen properly. So it shouldn't take long to actually sort this out and to actually get it to cure. Around about 10 to 15 seconds should be sufficient. Awesome. Absolutely awesome. Okay, so I'm going to get rid of the excess conformal coating that I've got just up here. It wouldn't hurt the board, but I'd rather not leave it there. Just clean that away. And this time I'm actually going to add flux just to help me out a little bit. So I'm going to add a layer of flux here. And I'm going to grab another chip. So that chip that I've just replaced that went wrong, I could probably reball that, but honestly it's not worth risking a warranty job coming back for it. Not for the sake of £7. Cuts into profits a little bit, but it is what it is. Okay, so I'm going to make sure that this is in line. That seems a little bit better. Okay, so let's flow this into place. While I'm at it, Okay, I'm going to add some more flux then. Okay, and that is springing nicely back into line, so we should be good to go with that. So I'm going to give that a couple of minutes to cool down, and in the meantime I'm going to clean off the APU, and I'm also going to clean the inside of the case as well. Add some fresh thermal paste ready, and then I'll pause the video for a minute while I'm letting this cool down, and then I'll resume once I've cleaned the chassis out. Okay, ladies and gents, so this is clean-ish. So let's just get this back inside the housing. I'm going to pop that to one side for a couple of minutes, just while I screw these down. And I always do this. I forget to plug the fan. I forget to hook the fan up. Usually I put the motherboard back in by the time I realise, but I guess I was a little bit luckier today in that I realised immediately. And I am very sorry about the dogs barking. Unfortunately, they're not my dogs, and there's nothing that I can really do about it. Okay, so let's first of all, before I actually put it into the chassis, I want to check and make sure that it turns on. And I also need to clean the motherboard as well, because there's flux everywhere. Still not turning on. Okay, well, I'm going to give it another reflow. I need more flux. Okay. Something's not normal here. It appears to be in line, yet they're not working. I might just end up reboarding this thing. That is definitely in place. There you go. Awesome, that turns on. Really not sure why that wasn't working as it should, but that appears to be working now, so let's give this a clean and get it back inside the case for testing. That was really weird. Turn it on. We get fan spin, which is a good sign. Let's see if we get power to the front USB port. We do. So you can see there, that's lighting up. We get a white light. Yes. Excellent. Let's see if it's going to display. And yes, indeed it does. So let's just sort this out. We appear to have no controller sync. That's not good. Alright, let's try and boot it into safe mode. Let's see if we get controller sync in safe mode. Yes, we do, which means we probably have a Wi-Fi issue as well. Yeah, we also have a Wi-Fi issue. That's annoying. Well, I guess this is why we don't fully put it back together. I can't even test the disk drive because I can't get into the dashboard. Alright, so when we've got no controller sync, what that typically means is that the Wi-Fi IC has gone bad, and that's going to need replacing as well, which is just here. So we're going to have to replace the Wi-Fi IC. Okay, so there's the old Wi-Fi IC off. So just like with the safe bridge, we need to clean this up and prepare it for a new IC. So I'm going to add some flux, and just like before, I'm going to replace the solder that's on here with fresh leaded solder. And now I'm going to wick away the fresh solder I've just put down. Alright, so what I need to do now is I need to take a Wi-Fi IC from a donor board. And you can buy the Wi-Fi ICs from AliExpress and places like eBay and stuff like that, but I would much rather just take one from a donor board wherever possible. So this is the same board, it's a 1200 series board. So I'm going to take this off and re-ball it. Now the good thing about these is even though we can't get a stencil for them, or as far as I know we can't, it can be done by hand. There's not that many solder balls on there. Let's make sure that we don't put the old one back on. I've done that before. Alright, so here's the new Wi-Fi IC, or rather the replacement. Before I can install this, I need to prep it, and I need to re-ball it. So basically re-balling means to replace these solder balls with fresh solder balls. So we just clean that, or rather replace the solder that's there, just to make sure we don't damage the pads, and then wick it away. I'm going to clean that up. I'm just going to scrub it with IPA and a toothbrush, just get rid of all of that burnt flux, and then give it a visual inspection, make sure it's nice and flat, and then feel it as well, and yeah, that's good. So to re-ball it, we're going to need to replace the solder balls. And the solder balls I use for the Wi-Fi IC are 0.76mm. So we just add some flux, a nice even layer. This is where you want to make sure there's a nice even layer, because we don't want a big puddle of flux to build up on the chip, because otherwise that moves the solder balls out of the way. So the solder balls that I use are 0.76mm for the Wi-Fi IC. And just sprinkle some around the chip, and then using a pair of tweezers I'll manually place these solder balls onto each of the pads. Don't have to be exact, because when they melt they will basically be good to go and they'll just spread out on the pad. So I'll fast forward through this, but all I'm doing is just basically spreading these solder balls out into the correct locations, and then I can melt the solder so as it flows onto the pads as if it come from factory. So they do look too small, but trust me, they're absolutely fine. You could double up on these, and put 2 on. But as long as it makes a nice solid contact with the board, that's all you need. So I'm actually going to move the microscope out of the way. Relay. Oh my god. Yeah, I should have put the lid back on. Well, that'll teach me. It won't, because I do it all the time. The good thing about the 0.76mm balls is the only thing I use them for is the Wi-Fi IC. There's probably 100,000 balls there. Never mind. Right, so I'm going to reball this really quickly. I don't tend to use a microscope for these ones. It's just a lot easier on the eyes to do it by hand and by eye. Okay, and they're all in place. So I'm just going to remove any excess balls that are sat on top of the chip. And then I'm going to flow it down using some hot air. So I'm going to set my hot air to 5%. And then I'm going to flow these solder balls into place. Okay, so now that's done, I'm going to add some more flux. If I can find where I've put it now, I've just made a complete mess of everything. And wait for it to cool down a second. And then just reflow it using 30% air, 480 degrees Celsius. Okay, and there you go. One freshly reballed Wi-Fi IC. Just going to get that roughly in line. It doesn't matter so much with this one because there's not as many balls, so as long as it's fairly close to being in line, it will put itself in. Okay, I'm going to add some more flux. And then flow it down into place properly. Done. Alright, so I'm going to add a little bit more thermal paste here, just to make sure there's enough. Not a lot, just a little bit. So let's hope that the disk drive actually works. Well, presuming we can get the Wi-Fi to work. Not Wi-Fi, the controller sync. But let's hope that the disk drive works, because I don't really want to be spending any more time on this console. And I'm pretty sure that the customer doesn't want to spend any more money. Alright, let's switch over to the capture card. And there we go. So we booted into the OS now. Yes, we have controller sync. Awesome. Oh, what am I doing? I need that. The battery don't work on this. Okay. Time for the ultimate test then. Let's test the Wi-Fi. Let's check the sound on the screen first. See if we're in. Yep, we're in automatic, so that should be in 1080p. Network. Set up internet. Picks up the Wi-Fi. There's a very important message on this Wi-Fi password. You should really pay attention to that password and do as it says. Please. Okay, test internet. Awesome. Okay, so let's pop a disc in. No, it's still going to need a replacement laser. That sucks. Well, that sucks pretty bad. I mean, the main console is working, that is a good thing. But the thing that sucks is it's going to need a new disk drive laser. So this is turning out to be a fairly expensive repair. Right, so sadly I don't have a replacement laser that I can use. So Console Repair London, the company that sent this machine to me, will do the laser replacement on my behalf. And I'll just bill for the sales bridge and for the Wi-Fi IC. But yeah, just to summarise on this then, so this was sent in for, well, the main issue was no power, and generally a no power issue is caused by a faulty south bridge. So by reflowing the south bridge it turned on, and by replacing the south bridge it means that there's a brand new south bridge on there, so we shouldn't have this issue moving forward. Now the first one didn't go to plan, it didn't install properly, that's completely my fault, just being a little bit sloppy there, but the second one seemed to go okay eventually, and yeah, this console can live again. So like I said, I don't have a replacement disk drive laser, otherwise I would have done that on the video as well, but unfortunately there's just nothing I can do about it if I haven't got the parts. I don't generally get disk drive repairs. I've got loads for the original 1000 series, but none for the 1200 series, but never mind, it is what it is. Console Repair London will take care of that. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. I will always do my best to answer, and if I don't have an answer for your question, I'm sure one of the community members will. If you want to organise your own repair, there will be some links in the video description where you can get in touch by email and then send the console down to me to repair. If you like what you see and you're brand new to the channel, be sure to hit that subscribe button and turn on the bell notifications so that you're notified every time that I upload. And if you appreciate what I do, all of the tutorials and things that I'm doing on different issues, then you can support the channel by clicking on the Patreon link in the video description, or by becoming a channel member using the join button below the video. But that's going to be it for this video. Thank you very much for watching, and until next time, I'll see you later. Bye for now.